So let's see. So yeah, the topic is on code organization. I don't know if I should sit or stand. I'll start with sitting, and then let's see. But just I want to kind of see where is the audience in regards to Go. So who used Go for more than half a year? Raise up your hands. Okay, so like 50% maybe, 40. So who used Go for 1 month or less? So pretty much none experience or less than 1 month. 1, 2, 1, 2. Wait, keep your 1, 2, 3, 4. Okay, and okay, that's good to hear. So actually, to warm up, I decided to make this presentation less about Go and more about general principles in code organization that at least personally affected me and how I think about it. And in the end, if we have time, we can go into more Go-specific stuff. But I found out with experience that for me personally, very general software engineering principles always worked in whatever language I work on. And then, of course, you add some, let's say, idioms or conventions on the language on top of that. But usually those are easier to learn than some general concepts, for example, like modularity, keeping your things loosely coupled, etc. But also, yeah, Palo Alto Club was mentioned. Very nice that we're here and we can have this meetup offline. It's been a long time, I think, since we had an offline meetup. Kari, by the way, is the lady who kind of let it all happen, and she's a manager in this space. She asked me personally to keep the space clean and everything, so I'm responsible for it. So just saying, also, like, try to keep it nice and clean. One more mention, special mention is to Veljo. Veljo is, Veljo is providing for us the live streaming of event. So all the video setup that you see is his work, and he's doing it for us for free. And this is amazing. So this is really, really great. And by the way, Veljo, I work with Veljo in the same team in our company, Better Medicine. And Veljo is an amazing teammate. And also Thomas, my another teammate, helps him with the video setup. So let's give them also a round of applause. Okay, a little bit about me. So I'm CTO and co-founder at Better Medicine AI. So we help radiologists do cancer diagnostics more accurately and faster by analyzing computer tomography images and overlaying those with potential tumors or cysts and doing, for example, automatic measurements of those lesions. Previously, I worked in Starship, optimized robot delivers in real time. And before that, I worked in fintech TransferWise, or recently renamed to Wise. I worked there on public API design, implementations, integration with banks and partners, and later in anti-money laundering team. Yeah, I started to use Go in Starship. So I've been using Go, I think, for maybe 4.5 years, more or less, maybe even a little bit more. And yeah, I blog a little bit of Lakusta.com. Should probably do it much more. But in my free time, I like to do Brazilian Jiu-Jitsu. This is the picture. I do barefoot running in snow. People think I'm a little bit crazy, but yeah, and they ask me why I do it. It's hard to answer this. And yeah, do gymnastic rings and raise my 4-year-old son, Luca. Okay, topics covered. So actually, we will look at the code organization from the perspective of domain-driven design and why it's important. Then in the context of microservices versus modular monolith, how to go about it or how to reason about it. Little mention about hexagonal architecture, also dependency trees in Go, and code organization for prototyping versus long-term maintenance. Maybe some recommended readings. And if we have time, I might show you the demo of how is our code organization in the repository for Better Medicine, but we'll see if we have time for that. So let's get started. So who knows about domain-driven design? Raise your hands. Okay, so like half. So this is actually good to cover that. So because if everyone would be expert in domain-driven design, then I would have like skipped my talk and just go to the next presenter right away. But yeah, domain-driven design was first described by Eric Evans in his book in 2003. It's a seminal book, definitely recommended reading. And well, it doesn't require any specific architecture, but its main points or discuss how to separate infrastructure concerns from the business concerns and how to make those business concerns, or let's say domain, much more explicit and understandable both for engineers and stakeholders. And yeah, it centers the development on programming a domain model that has this rich understanding of the processes and rules of a domain, and talking a lot to the, let's say, domain experts or stakeholders, whoever they are, and then translating that into your code. So what are, for example, technical concerns that we want to separate away from business concerns? This could be things like database, AWS session, or whatever other cloud provider you use, configuration management, logging, what else? Metrics, for example, if you use Prometheus, or messaging, Kafka, other things. And what are business concerns? Well, business concerns are things that your business or product like core is about. For example, if you have a pricing logic, how do we apply the discount for the customer? Or if it's an auth logic, does this user have authorized access to feature ABC? Et cetera, et cetera. Or could be other specific core domain logic. Let's say you have a specific algorithms, how you do a recommender system, or anything else. An example also on the domain and subdomains. And this is where we get into, let's say, bounded context or organization of code. So imagine you have a online auction like eBay, right? Everyone knows eBay. So this is just the domain, right? Online auction. But once you get more familiar with the domain, you can see that it eventually gets broken down to different subdomains, right? So for example, the online auction can consist of the, seller, auction, listing, membership, and maybe this conflict resolution or dispute resolution. And yeah, then this, I think, just have to understand that you don't have this, how to say, very crystallized understanding right from the beginning when you start the project. So you might, for example, start with a monolith, start it out, but once your subdomains become more explicit, you can start to split them. But then the question comes, well, you can split them, but then, yeah, how do you do the splitting? So we can also think about each subdomain in a context of bounded context, is that it contains a well-defined subdomain. It has very little coupling to other subdomains, and it talks to other subdomains through a very well-defined interfaces. And yeah, it fulfills some business use cases. So it doesn't just, does some CRUD operations. It's very service-oriented, and it does the whole, let's say, use case. So for example, in the example of conflict resolution or dispute resolution in our auction, this would handle, maybe even storing the, these disputes or resolutions and talking to all other pieces via well-defined interfaces. And yeah, you can think about bounded context like borders of the country. So let's say in your companies where you work, if you have microservices, right, or if you have other things, you have very well-defined APIs, and no one can do something or affect your service unless they talk through this well-defined APIs. And it means you can control which input you get in, you can control validation, you can control responses, everything, and you know that you will not end up in a corrupt state, right? But now imagine, and probably raise your hands if some of you worked with microservices, and also sometimes called distributed monolith, where each microservices talk to one database, and it was the most hell you ever had, and no one likes it. Raise your hands. Okay, I see many hands. So no one likes it, right? No one likes when somebody messes up with the logic of your whatever service through a database, and then like disregards all the rules that your team sets up. No one likes that. So you have to adhere to the borders. And by the way, when I talk about this, you can conceptually translate it to any package or thing you develop, because you can think, for example, if you develop some package which has some API, you have to define a very well-defined public API which other clients interact with your package for you not to end up in invalid state. And the same applies to the higher level when you talk about microservices, and yeah, you go in higher levels. So yeah, be on your guard, define APIs, and think how people interact with your either a module in a monolith or let's say a microservice, whatever, let's say your bounded context is. And yeah, the DDD explains very well how to split monolith into these bounded contexts based on the subdomain. So the split should be correct. This is also important. So you try to, Because if you think about it, the concepts or logic in subdomain is very cohesive to each other. And if you split wrongly, then you might end up in one service talking to another in a very highly coupled way. And yeah, it might become a little bit messy, and your modules will not be loosely coupled. So you have to really think well how to split sort of your pieces into correct subdomains. And yeah, and the technical patterns of DDD talk about how do we organize code inside of a bonded context. Let's say you have a microservice. How do you organize code well inside of this microservice? Maybe we then talk about this organization. Let's say you've been able to split correctly your subdomains. You have well-defined bounded contexts. And inside of this, let's say one microservice or service or monolith, doesn't even matter, honestly. It can be modular monolith. You think, okay, how to organize the code? So the first main principles is dependency inversion, right? So for whom this graph is familiar, like raise the hands, or who knows, or follows the principles of from this graph. So the idea from this graph is that this graph, in a way, explains how do you separate technical concerns from your business concerns and keep things modular. So if we look closely, we can see that the inner layers, let's start from the inner layer, the domain layer. The domain layer may contain some of the, let's say, business core logic, which doesn't depend on your which database you have, right? It doesn't care if you have Postgres or if you have Redis or whatever you have. This is just the business rules that hold true, and no matter what other tech you use. If you replace Kafka with some other technology, this layer wouldn't care. Like, it doesn't care. For example, it might be I don't know, tax logic, tax calculations, right? So we want to keep this layer and not depend on this layer, let's say, not mess this layer with the persistence layer. And this is what usually happens in the big ball of mud, right? Whenever you want to swap the databases or change something, you affect everything. And usually what it may happen, you want to change the, let's say, replace Kafka with something else or make a change there, but suddenly you make a bug which affects the domain logic, right? And we want to avoid that. So the domain layer doesn't depend on anything else pretty much. Well, it may depend on standard library, other things, but nothing infrastructure related to let's say, it shouldn't know anything whether you use AWS or Google Cloud or which database you use or which SMS provider you use, Twilio or something else. And the application service is similar, is that, you know, this whole circle, it cares about business logic, and the application service fulfills the whole use case. So let's say if you want to create a user, the application service would have steps like see if the user is in some repository, and then if it's not there, create it. Maybe create with some domain rules, and it would talk to domain layer. So application service depends on domain layer, but not vice versa. And then yeah, it will fulfill the use case. So for example, when it creates the user, for example, it might see if the user got registered with some referral code. Let's say if you got an invitation link, if yes, it would apply 30% discount for the user, and then return successful response. But the application service itself, let's say if it needs to talk to the persistence layer, it defines an interface how it talks to this abstract repository. So for example, an application service would have an adapter. So if you look at my cursor here, the application service, let's say, would define, if familiar for your repository pattern, right, or repository layer, let's say user repository. But user repository would define methods such as, for example, create user. But the application service itself doesn't know let's say, doesn't know which database it talks to, right? Because later on, we will have an adapter, let's say a Postgres package, which would implement the interface of user repository to implement, let's say, the method which creates the user, or then later deletes the user, modify all the usual operations. So in this way, whenever we need to, for example, swap the Postgres layer with, let's say, in-memory database for integration testing or any other database later on, our application service doesn't have to change, because it shouldn't change, right? Because it only cares to create the user, and how you create the user, this is up to your infrastructure concerns. The same can apply to messaging. Let's say you need to publish a message that user has been created. Again, you don't need to care about the Kafka in application service. You can just define an interface, for example, messaging service, and which has a method publish. And then later on in your application, let's say in your main.go, you would inject a specific implementation of the messaging service, which will conform to the interface controlled and defined by application service. Right? So this way, this is called dependency inversion principle, where your inner layers like know nothing about the outer layers. So you invert the dependency, because application service now doesn't directly depend on the Postgres, but yeah, in runtime in main.go, we just provided as a, we injected the real implementation to adhere to the interface. So this is the main idea. If we have time for demo, I might show you some example of that. But this is, at least for me, one of, let's say, the main graphs, or it's like, you know, TLDR version of how I think about the structure in a long-term maintenance of application. Of course, if you start prototyping, you don't have to start with a structure. But if you think about long-term maintenance, this is usually how it is in my head, how I think about, you know, code organization, or inside some bounded context, be it microservice or monolith or whatever you have. So yeah, again, another referral is to hexagonal architecture, which honestly pretty much is the same as this graph. But yeah, it was popularized by Robert Martin in his book Clean Architecture. This talks about the same thing pretty much. You have application core, which in this other example, you can think about this service layer, application service, and domain layers. And here you can organize it as much as you want. But the idea, for example, if application core needs something related to persistence, it defines an interface, and then you have adapters. Let's say a DB adapter, which you then wire in, let's say, your main.go or wherever through dependency injection library. But yeah, you have DB adapter, you can have file adapter or in-memory adapter, which will adhere to this persistence interface defined by application core. And same goes with other things like notifications and other things. This way you have loosely coupled systems, and your business-specific concerns evolve, let's say, at a different speed than your infrastructure concerns. And you can kind of evolve them separately. Yeah, and one more thing is also surprisingly related to code organization is ubiquitous language. And ubiquitous language was, again, this term was popularized by Eric Evans from Domain-Driven Design. And it talks about the fact that you have to define your terminology and language in your bounding context very specifically. And again, you can think about it as, again, if bounding context is a border of your country, right? Whenever you cross the border, it's like another language. So you know how usually they make jokes that, I know Estonians make jokes with Finnish that one word in Estonian, like for example, the same word means completely different thing in Finland. There was some look about wedding or something. Something that is wedding in Finland means like, I don't know, sorrow in Estonian or something similar, no? Veljo doesn't know, okay. But the idea is, for example, why I mentioned this is that, for example, the user or the customer in one bounding context can mean absolutely different from the customer in another bounding context. But you have to define those terms very well. And you even want to write it down. So it's like really a glossary of domain terms. So for example, in our company, Better Medicine, we defined very well what we mean by annotation and what we mean by segmentation and let's say a bunch of other concepts. So we know specifically what we mean when we talk about that, and we keep it consistent in our code. And this is very important because everyone probably knows or worked in a code base where it says one thing, but then your teammate, especially if you just joined the team, but they say, no, this is, it says it is registered user, but you know, actually it's unregistered user, or you know, like it's just this name, but disregarded because it was a historical reason. This actually means completely different thing. And I had this case a lot of times. Yeah, I can see some hands raised, yeah. So, and this annoys you to, like, you're like, why you have to do this? But the idea is, well, you can avoid it by continuous refactoring, but also by agreeing on this, what's called a linguistic consistency. And this actually helps a lot with communication. And why I'm talking about this at all during code organization, Well, because it helps you to, organization is about code understanding, right? So it helps you to organize ideas and code when you talk about stuff in a similar or same way. And you'll be surprised by, if you go probably in your company now and make this experiment, what people mean by different words, especially the most ambiguous ones. You will hear a lot of like different, let's say, opinions, or one person, for example, in your code, it may be one name, but when you talk to domain people, they have no idea what you mean. So you want to have this linguistic consistency, and ideally, whenever you talk to domain experts in your field, it's the same word that you later use in your code. And this is really the best way to kind of align those. And yeah, whenever, for example, domain expert starts to mention some other word, which is not wherever mentioned in your code, but you have logic related to that, well, you better actually start naming it the same way. Because then you kind of have a communication with your domain experts in a very correct way, and it helps you a lot. So yeah, this is what's called a ubiquitous language, and it will evolve over time, of course. And you can refactor. You can refactor your glossary to reflect this and your code, right? So, and another interesting concept is if you find a grouping of complex logic to appear, let's say you deal with some, I don't know, discounts, user discounts, and you, I don't know, let's say it becomes super complex. Maybe if it's super complex, but you kind of see a pattern, maybe name it somehow. I don't know, for example, like, I don't know, I'm just making things up. If, for example, user invites more than 50 people, he will get, for example, some next level of promotion. So next level of discount. So you can kind of call it some way to refer succinctly this concept to everyone else. So an example from math, well, I studied applied math, and I remember when I studied integral, you know, there's this long definition of integral. It's a sum of things, of these small bits of, you know, the function with a small dx, and it's a very specific definition. But then, you know, you have this one-page definition, which gets reduced to this, you know, integral. And then everyone understands what it is. And of course, if you just, you know, start with integral, you don't know what it is, you go back to definition. But over time, it actually helps people to communicate, because now you have a succinct concept, which reduces this cognitive overload in the long term. And yeah, it helps quite a bit. Yeah, so you can think about button context as a microservice, but I would even suggest to start thinking about button context as a separate module in a modular monolith, right? Because we sometimes start very quickly with separating microservices, and I saw many people raise their hands when I said that, hey, you use one database for different microservices, and everyone laughed because they know that the database integration is quite tricky, and pretty much everyone ends up in some corrupt state, and it's not a loosely coupled system. So I would encourage people to first think how they can split the subdomain or make this button context inside the monolith, define clear APIs, and if you can think about it, these APIs can be, I mean, it can be a function call, right? You can define an interface. You don't have to make a network call at all. You will avoid many problems in a distributed systems right away, and you can start refactoring in monolith. Let's say your bounded context, define clear APIs around it. Plus, then, for example, introduce a separate persistence for that, let's say a separate database, if it needs to have one. Then your other code will only talk to this bounded context through a well-defined API, which again can be just, you know, compile time. I mean, it can be just calls, function calls, method calls, whatever, service calls. And then you can think about, okay, maybe now it's so much easier to replace it with a microservice, because now the only thing I have to do is replace those, you know, function method service calls with network API calls. But now you have a very clear interface. You quickly refactored and iterated in your monolith, and now you actually have microservice which is loosely coupled with other services via well-defined API, right? So why I'm talking about it also in the context of microservices, because we know that, you know, code organization is not just, we don't always care about it just in the one service, but today we care about it, let's say, for the system as a whole, right? How do we organize our code? How do we organize our logic? So it's a like deeper question or more broad question than just organizing code in one service. But even if it's in one service, you ask yourself, okay, how do I for example, when do I split? How do I define, the boundaries and when? And it might be, for example, why I prefer this approach first to just splitting right away to microservice, because you might end up, imagine you split things in a monolith for a month, and then you see that maybe things are not quite that right. Maybe you didn't correctly split things. Maybe one part of logic actually should be in another service. So you can quickly experiment it and refactor before you move it into a separate microservice. Okay, another interesting concept is context mapping, and this is pretty much mapping your current situation with your services or a system as a whole, and it answers questions, for example, usually we talk in the context of teams. I mean, in our company, we're an early stage startup, and we have pretty much one software engineering or product engineering team, and one AI engineering team. So we pretty much handle all the services related to software engineering. But when I worked in Starship and TransferWise, we have many teams, multiple teams, and usually you care as your team, who do you talk to, or which of your services that you own, how do they talk to other services, and can there be some improvements made? So what you can do, you can map it out. And you can, in the context mapping, I'll refer, by the way, further reading for this, but you can actually, it's important to notify which kind of relationship it has with other bounding contexts. Is it upstream? Is it downstream? And there are many other terms that you can use. And the most important thing is it represents your not perfect reality, because everyone knows that there is no, you don't have a perfect architecture, and it's fine. But as long as you map the current situation, you can strategize and think how you can change it. So, I mean, this is just one example. You can, for example, say that, context C is complete big ball of mud, it's upstream. The downstream context is this. ACL stands for anti-corruption layer. And there are many other terms you can use. For example, this means that they have a shared kernel, meaning that there is actually a common code that is shared among two bounding contexts, usually maybe in the form of a library. But yeah, the idea is that it's actually the same code that is used. And yeah, there are many other terms. So most common is called partnership. For example, when teams in two contexts succeed or fail together, customer supplier, shared kernel, conformist. Conformist is an interesting one. For example, upstream has no motivation to provide for downstream team's needs. Have you ever had a situation where your team needs something, some changes in API, but the other team is like, nope, we don't care about it, sorry. And yeah, I mean, fine, but at least write it down, and maybe then it gives you some ideas how to go about it. Yeah, open host means that, for example, your system is open to everyone, that needs, everyone can integrate with your system. And anti-corruption layer is a specific layer, for example, to isolate or limit impact to your upstream system. So, for example, you can isolate your API with the anti-corruption layer, and whatever changes downstream, you kind of have this ACL that takes care of it. There's a further reading, by the way. I'll share the slides so you can check it out. I think it's quite nice reading as well. And yeah, another topic is code organization for prototyping versus long-term maintenance. So when we prototype, I mean, definitely don't go crazy with all the principles from DDD. You don't have maybe to use the separate domain layer, separate application layer, separate infrastructure layer. Maybe just fail fast, and go with the minimal hierarchy, keep it flat. Well, maybe separate something as long as it helps you and gives value. For example, I like to follow TDD pretty much from the beginning of the project. So, for example, I would create a necessary testability for the module, but at the same time, keep it as flat as possible with minimal hierarchy. But the long-term maintenance, definitely go ahead and refactor into this more, let's say, better structures, which will keep your components loosely coupled and more testable. Plus, you will separate in this way infrastructure concerns from business concerns. And well, an example would be repository pattern, right? This actually achieves that. So we know that, remember I showed this graph of the, let me go back to this so you actually see. So imagine actually this part. So this specific where my cursor is, if you see my cursor. So this part, let's say, defines an interface, and in our case, let's say it's a repository for some, I don't know, user repository or some other, which cares about the persistence of a user, or can be some other entity, task repository, anything else you have. So this application service defines an interface which is abstract, and then later on this Postgres layer can, or whatever DB layer can implement it. But the application service doesn't know anything about it. When it fulfills the use case, it just talks, it just has this repository as a dependency. So if we go back again, it's just literally I took the screenshot today from our code, from our repository, from our monolith. But pretty much we define a repository. It's a study repository, and it has some methods. But you can see they are, in a way, abstract. They just talk about, hey, I want to create a study, I want to find by ID the study, or I want to find all studies. And then in the application service layer, well, it just has repository as a dependency, and it just says, hey, repository, find me all. And as you can see here, we have no dependencies on the database layer, or Postgres, let's say, even though we use Postgres. But later on, the Postgres layer will have implementation for this repository. So we can have, for example, Postgres study repository, which will implement those interfaces, and we will inject it as a dependency for the service that needs this repository to function. Right? So this is dependency inversion principle. And in this case, it was the example of repository. And yeah, wrapping everything up so far. So you can think about it, microservice as bounded context, where again, you need to keep your boundaries. Or again, think about it maybe as a module in a monolith. And define boundaries of your bounded context. Really think about it as the border of your country, and you have to guard it. You know, it's the same if you talk to any public API, right? You have no other way to access their service rather than talk to the public API. And this is great because it gives them a very huge amount of control to change their service as they want while keeping the public API as stable as possible, right? Same principle in your microservices or whatever architecture you have to talk to other systems, and even in your monolith. You can think about your monolith and your packages as having public APIs, and you can think about your internals as, I have them internal, no one touches that, no one knows about it, but I expose my public API and, you know, think about that. Again, yeah, you integrate through well-thought-out interfaces, use ubiquitous language to, inside your bounded context, to crystallize your domain terms in your context. Use context mapping to see this reality of how your services interact with other services. And inside a bounded context, use this principle of dependency inversion. And we saw it on the example of repository pattern to separate infrastructure concerns from business concerns. Now more like, so far my talk was not about Go, right? And you probably all Go enthusiasts are disappointed or something. But yeah, well, in Go, actually, there are good news. They don't allow you to have circular dependencies. And I'm sure the Go newcomers, they come to language and they have a first circular dependency. And they're like, what the heck? Like, why I have a compile time error? And first, I remember I was disappointed. I was like, why? I want it to work because it works in JavaScript or some other language. But it actually turns out a good thing. And we who used Go for a while, we know that. Because it forces engineers to think about the better and simpler software design that avoids circular dependency. And I just, actually today I read Reddit, and one guy asked like, yeah, what's the way to solve this circular dependency? And he had some structure where he had a global package, router, data, and domain. And his dependencies were the follows. Like the main, of course, takes everything as dependency because it wires everything up. This is okay. But then he has this interesting thing where global package, you know, dependent on data and router dependent on global. So you have a circular dependency. Global depends on router depends on global. So the issue was that the global package depends on router to get some structs definitions, but then router depends on global to get the database connection. So again, this is the bad design. Maybe you start by creating a separate Postgres or database package. Many ways to solve that, but definitely avoiding circular dependencies keeps your design simpler and better. About the further readings, I very wholeheartedly recommend this book by Scott Millett. That's actually what started me with domain-driven design. One guy in TransferWise recommended me this book even over the classical book because he said it contains more examples, which it did. It was great. But of course, you can also read the classical book. There's a nice book by Sam Newman on building microservices. He talks there also about DDD, of course, and bounded contexts. and talks about, yeah, don't rush to split to the microservices prematurely. But if you do, he talks about integration patterns. And Martin Fowler, of course, has innumerable articles about different topics like button context, ubiquitous language, breaking monolith into microservices. He talks about patterns like strangler pattern, etc. And I'm very well aware that I talked very little about Go-specific organization things. That's why I actually want to wrap up with demo, if I have time. Let's see. But if you want to actually go deeper, you can go to this repository. It's an amazing repository, which actually gives an overview of different directories in Go and how they may be used. And again, it doesn't mean you have to use all of it, like here. But for example, you will understand, okay, how the command folder is used most of the time. This is usually an entry point, right, to your applications. Why internal is used, package, vendor, /API, /web, /configs, etc., etc. It's a very good resource. And I didn't want to keep my talk tactical and talk about these nitty-gritty details. You can find it. You can follow many open source examples, and you can browse through these examples. I think they will give you a very good overview. Also, I referred the article on this context map, and our own Egon, who is there, has an amazing blog, and he actually has also his own good take on thoughts on code organization and psychology of code readability. I definitely recommend it. He talks also maybe in more detail how to organize code by, let's say, by value, by structure, or by, like, let's say, different features, and how you can think about it. So I kind of, first I thought I might include some of the pieces from his articles, but then I wanted to focus more on DDD concepts and button context, and then I thought I would just refer it for further reading, but I definitely recommend it. It's a very good read. Before we go to Q&A, let me risk and do the demo. It's going to be a 2-minute demo, and it's going to be really of our latest snapshot of master of our repository. And Valio today said, or Thomas, wait, but it's not perfect. How can we show it in the demo if it's not perfect? And I said, that's the point. Everyone talks about perfect stuff during presentations, and we will show some non-perfect stuff, and that's okay. We will not show any sensitive code, so don't worry, or so I hope. But let me go to presentation mode in the IntelliJ to make it happen. So, Egon, if you are a timekeeper, I hope I have 5 minutes for the demo. Yeah, okay, amazing. So, let me just do this. So, it's hard to take the microphone. So, this is our Better Medicine gateway. It was called the gateway for historical reasons. But this, for now, includes, this actually has 2 main services. It's pseudonymizer, and this service is responsible for getting computer tomography images from hospital network and eventually uploading them to our Google Cloud, but in a very secure way. And there is a lot going there. But pretty much we anonymize it, making sure we only send to our cloud only a non-sensitive data agreed preliminary with the hospital. So yeah, this is like an important service. And another important service is viewer API. So we currently, for example, work on the fork of one medical image viewer, and this is the backend for it, the API. The frontend is in a different place. And there are other, let's say, mostly scripts or tools that we use, which are not, let's say, maybe runtime applications. But let's take a look maybe at, let's see, the pseudonymizer. So you can see, well, for example, we use the internal package. Again, doesn't have to be used, but the idea of the internal, this is, by the way, the convention, is nothing from the internal can be exported from the, let's say, parents of this folder from other directories. So for example, from viewer API, I cannot export any code that is in the internal of this. And this sort of just makes sure we don't accidentally import something, and we keep it internal. But here you can see we have a separate domain layer. And you can see domain layer, for example, has rules for whitelisting. I won't go into the file itself. Maybe it's a little bit, you can say, sensitive. But we have, for example, obfuscation spec rules, how we handle bytes, even obfuscated bytes, etc. But it has the thing is that this package has no dependency on any other package pretty much, except the standard library and maybe some like other libraries that we use, but no infrastructure concerns here. Then we have a services package, which actually fulfills the whole use case. For example, pseudonymization, which is this process where we anonymize data. But again, it doesn't know anything about the Postgres database. So for example, the Postgres, I can show you, we have a repository, right? But this just implements the repository interface, which is, it just implements the repository interface, which is defined in the service layer. So if I go here, you can see this is interface, right? So just for you to understand again, the dependency inversion principle is that the Postgres package just implements this interface, which is defined in the service layer, and then in the main, we just give this instance of the actual repository to, let's say, inject it as a dependency in the service. Okay, I mean, yeah, these are just the mocks. We use the mock library for that. By the way, I recommend it. If I mean, there are many other ways to mock, but we use this MOQ library to mock interfaces with like mock implementations, which just track invocations and stuff, which we can use in tests. Yeah, what other thing? The infrastructure things mostly are just, again, adapters to the services. Maybe I show you, again, now we keep everything in kind of one structure. Maybe we will split later. But we did it on purpose because for now, for example, we were not sure, kind of even the packages we keep global. For example, the package has BM logs, and it has our interface for the logger, which we defined. And currently this, for example, logger in implementations is used inside both, let's say, two of the projects. But it's as a separate package right now. Yeah, and we have, for example, can have implementations for logger, you know, which just prints to std out, and the cloud logger, which would print to, or which will send the logs to Google Cloud if we need to. But the viewer API, another project, has a similar structure. For example, we have a folder for CI/CD, which has different Docker files and other stuff we need. It has invocation point. So for example, the main.go, you can see it just wires things up. So this actually wires things up based on real implementations, and then injects those dependencies into other services, and then pretty much just there's a server, we use the gin, and then it runs, you know. But here we pretty much wire up dependencies. And again, it can look very, how to say, scary right now, but if you see our main is only 100 lines of code, and we wire dependencies manually. Yeah, I know, people who come from Java world, and you tell them that we wire dependencies manually and don't use anything like Spring, they're like, what? Is this even possible? But yeah, but of course, I mean, if it grows up, you can use a dependency framework like Google Wire, or I think now with generics, there are even some generics dependency libraries that leverage generics in Go. Anyway, and yeah, you can see Viewer API also has the domain-specific things, which relate, again, anything only related to domain, how we treat annotations, segmentations. Again, this is based on our glossary of terms. So we have actually a glossary in Confluence, and we know exactly what we mean by segmentation, right? And again, the Postgres layer is just like an adapter. It just adapts to the interfaces defined by service layer. So you can see, for example, that service layer or domain layer, depends where you put them. But the idea, for example, that if I go to study service, I hope I don't show anything sensitive, it's just an interface, and here we have some dependencies. But again, the dependency is just an interface, and then later on we implement this interface in the Postgres. But this is just one example of dependency inversion. It can be the same with messaging service, the same with logger, and yeah, the principle goes on. So this works for us. Again, this is not ideal, but it enables us to have a testability of all the layers. We can test domain layer separately, service layer separately. We can have integration tests, wire things up. It's quite modular. It works for us. So, and later on, we might decide to split the viewer API into a separate microservice, and pseudonymizer and viewer API will live separately. Okay, I think it was a long time. Thanks very much. And maybe we have time for one, maybe maximum two questions. Yeah. Yeah, I'm gonna be here today, and you can contact me, yeah, as well. Okay, I'm gonna ask how long did it take me to figure out the code organization out? Well, I think, funnily enough, it didn't take much. So what I did is, for example, when Thomas and Value joined, we just discussed the same principles I discussed now, pretty much. How much of, like, for example, everything I talked? Well, I think for me the most, let's say, the book that affected me the most was this red one by Scott Millett. But this was pretty much my introduction to DDD. But he gives a lot of examples, like a lot of good examples. It's in C#, but it doesn't matter, honestly, because they can be applied anywhere. And I practiced them sort of in Starship then. You know, I kind of tested the ideas out. So that worked. So I don't know the answer. I guess in 1 month you can actually, how to say, be up to speed. So Value, for example, and Thomas, when they joined, they were definitely up to speed in 1 month. I think they onboarded very well. And yeah, Value before mostly dealt with front end, also some back end, but mostly front end. But he onboarded to this structure and kind of think very well. And again, there is no silver bullets. Sometimes we're like not sure where to put stuff or something, but I think principles and ideas still stay the same. Yeah, now rephrase. Yeah. Yeah. Yeah, I understand. So what you can have maybe, let's say if you have a, let's say it's the same stack Go, right? But there's two modules that just need to publish a message, and they both use Kafka, right? So your question is, will you copy paste code for the Kafka thing? No, I think you can actually just refactor it to a library, and for example, have a separate even interface, like, or even well, okay, interface can be copy paste. That's fine. If you want to. If not, you can even keep the interface separately in the library, and then implementations separately in the library, in some library, and then you just import this library in two projects. So that might be one way to, if it answers your question. This way, you actually import as a package. So you create a separate package which you can then import using Go modules stuff. So yeah. Thank you very much, and sorry for taking a little bit more time. Yeah.